Testing, testing. 1, 2, 3. Testing, testing. Wonderful. So how's everybody doing? Nearly forgot to turn on my face light. Jeez. Well, things are holding up pretty well around here. The cat is a little bit crazy today, but that might be on account of the fact that we're having something of a windstorm today, which is very interesting. Anyway, I don't know how things are in your part of the world, because you could be listening from pretty much anywhere, but we had a thunderstorm for all of 2 minutes, and there was no thunder, but it was otherwise a thunderstorm. Wow! Is 9 people really the best we can do on a Friday? Well, I guess we're just gonna have to live with what we got then. Yes! Yes, I do. He's looking at me right now. Perhaps we can have a meet and greet at some point. Anyway, So, a couple of... Oh, there he is. Come here. Come here, you. Oh, there we go. This is Martin. Martin the cat. Say hello to all of the folks out there, Martin. Oh, you just want to get away, huh? No? Okay. Here he is. Just, hey. Anyway. Yep, that's my cat. Anyway, a couple of interesting things have happened since the last time we met. Number one, I've had some requests from people to sort of dig up some additional resources in terms of practice problems, and I found a website which I think is actually pretty cool. It's W3 Resources, which I'm assuming is attached to the W3 Schools coding learning site. But the interesting thing about it is that it has a lot of Python practice with a lot of the more advanced topics that it's got the basic stuff too, but it's got a lot of advanced topic type practice problems in here. Stuff regarding, for example, recursion. There's even a thing on binary trees here, and a bunch of stuff that we haven't covered as well, like SQL databases and regular expressions. So that's a really good resource if any of you need some extra practice problems. So that's good. The other thing is that your professor made a slight error in his release of assignment 9, which is for next week, so it doesn't, the number of people who've probably started working on assignment 9 is probably pretty slim to begin with, but assignment 9, if you have fetched it, you will need to refetch it because I forgot to include the files that you were actually supposed to be reading from in the initial distribution. So if you wouldn't mind grabbing those and doing the assignment with them, that'll probably work better. Anyway, so let's continue on with our lecture, our series of lectures. So we were talking about classes. We have been talking about classes for a while now, which should give you some indication of how important a topic it's considered to be. I alluded to this in previous lectures, but when you're dealing with classes and dealing with methods, part of what you're trying to do is establish rules of engagement with respect to data. You're trying to establish manners of access of the data, specific manners in which data is used, specific manners in which data is set. One might say, in a more abstract terms, what you're doing is you're enforcing data policies and conventions. So when you are doing all of this work to enforce data policies, it's if you're not actually using the strength of the programming language to protect the data, you're not actually protecting the data from people who might be using it differently from how you might want your data policy to have that data accessed. What you're doing is you're saying, here's some methods. You might consider using these, you might not. It's up to you. However, if you start making some of the members of your class private as opposed to public, then that becomes an actual enforced data policy. It makes the attributes of a class inaccessible except by the methods of that class. This is generally considered to be a pretty good idea for various types of things. Some people think it's just a pain in the ass, but, you know. So, my recycling bin just blew over. Crap. Oh well. Nothing I can do about it now. So, with respect to Python, the manner in which you make any attribute in Python a private attribute is you preface that attribute's name with a double underscore. So let's look at an example. If you remember our mean calculator example from last class, we had an improved version of the mean calculator which used S and C to accumulate the running sum and the total number of objects that had been counted so far. However, those in the previous example and in all previous examples that we've talked about so far have been publicly accessible attributes. In this version of the mean calculator, both S and C are made into private attributes. This means that the only manner in which they can be accessed is by the methods that are contained within the class. So, yeah, it's as simple as that. It might be considered somewhat cumbersome to have to preface every single private member name by a double underscore every single time it's used. This is why in other programming languages, such as C#, what you have is a declaration of whether the attribute is private or public when that variable is declared. Sometimes I think that this is Python's way of dealing with the fact that it doesn't require actual instantiations. But, you know, it's kind of neither here nor there. Are there any questions about private members? Okay. Going to assume no, then. So, the rest of this set of slides is a thought exercise of how you might go about structuring a program using object-oriented programming in a larger, for something large, something that hopefully everybody has some point of reference with. And that is, of course, Mario. Pretty much everybody's played Mario, except for the people who haven't, of course. So, for those of you who don't know, Super Mario Brothers is a very, very, very popular series of video games where an Italian plumber jumps on things and over things and sometimes picks up mushrooms, which inexplicably cause him to double his size. So, what you see before you... Ooh, yeah. Yeah, the weather is terrible today. What you see before you is a sort of typical scene from a Mario Brothers game, even though it's not a typical scene from a Mario Brothers game. It's more like promotional material for a Mario Brothers game. But anyway, we have a number of things on screen, and I would like some ideas of what classes you might apply to a video game such as this. So, you may respond in chat. What do you think could be some applicable classes in this particular instance? Thanks for getting that. Okay. So we've got some suggestions. A class for player, a class for enemy, a class for block, and a class for power-up. Yep, this is a pretty good start. Are there any other suggestions? So let's consider block then. If we take block, what types of things are blocks? Like, how would you further subdivide that class into other types of things? What types of blocks are there in a Mario game? So, you want to group as many things as possible. Goombas and Koopas have the same base movement. Make that a parent enemy class, and have each subclass inherit. Yes, exactly. So, not only that, but you can think of. You notice in this particular instance, we have a couple of different types of Goombas here. We've got a normal Goomba, and we've got a Goomba with wings, or the ever-popular Paragoomba. Yes. So, one might imagine, since this winged property is a property which is shared across a few different things inside of this context, that you might have a class called wings, to which, if you apply, if you have a Goomba that is inheriting wings as well as inheriting all of the rest of the stuff that Goombas typically inherit, then you end up with a Paragoomba. A good way to think about this is just by show of hands in the audience, how many people here have played Mario Maker? So, for those of you who are not aware, the game Mario Maker was a game that Nintendo released where you could design your own custom Super Mario Brothers levels and then send them off on the internet and have other people from all over the world play them, essentially. And it was interesting because one of the things that you could do is you could take the wings that you now see attached to both the Goomba and the Koopa, and yeah, you could attach those wings to a large number of different types of objects, and they would always make that object float in some manner, or uh, you know, give some sort of aerial attribute to it. But the interpretation was slightly different for everything that the wings were attached to. But the other thing to keep in mind when you're talking about video games is that we're not necessarily just talking about wings as an abstract concept either, i.e. the attribute of apply... My God. The attribute of applying... Then how did you type that? If you don't have hands, how did you type that? Good Lord. What was I talking about? Yes. So the wings themselves, in addition to being sort of giving things aerial properties in an abstract way, the wings class would contain the actual model of the wings. So if you notice, if you look carefully at this Goomba and this Koopa here, the Koopas and the Goombas actually have the same model being used to indicate wings. They have the same, they're placed slightly differently on the bodies, but the wing is a sort of static attribute with respect to those two. So that's a thing to keep in mind when we're talking about things that are built in software. We're not always talking about things in the abstract. Sometimes we're talking about like actual models and sprites of things. So yeah, we already talked about this. So the slides propose the following as possible classes for a Super Mario level. First of all, there's the level itself, right? So the level would contain instances of all of the classes, of all of the things that are in the level, obviously. To make a level into a class would be a really useful way to organize the level itself. We have characters, playable, non-playable. We have widgets, pipes, and blocks. I would be more inclined to call these static versus dynamic assets. Things that move versus things that don't move. In that sense, in a Mario game, a lot of the pickups are actually dynamic assets rather than static assets in that sense. But, in terms of playable characters, you can imagine instances of the playable character that would be, Mario, the one Toad, the other Toad, and then the other guy. And then in terms of non-playable characters, you would have this, branching hierarchy of different types of enemies that go variations on all the different types of typical Mario enemies. With respect to blocks, you have almost precisely the same sort of organization as you would with enemies. They just have very different properties. Like the ability to be stood on without being destroyed, unless it's a donut lift. Yeah, so if you want to talk about some possible properties that you might apply to the classes that we're developing for these Super Mario type classes, if you have a playable character like Mario himself, you might have such attributes as name, whether he is big, whether he has had a feather, the number of coins he has collected, the X and Y coordinate of the character. You might also have methods, like move to a point, collect a coin, and the ever useful draw my character on the screen. Since a question block does a lot less, it would have a lot less going on. It would definitely have an X and Y coordinate. It would have a contents, which may or may not be null. It would have whether or not it's been used, and there would be some sort of action method that would indicate that Mario had hit the question block. In this case, it's being called smash, and of course a draw on screen method as well. So that rounds out our set of slides on the subject of classes. I was thinking that it might be interesting and useful for the class to take a look at a real-world example. But I have a comment. I swear you got these from a Construct 2 Mario tutorial. I've watched one in high school. Well, I didn't make the slides, so your accusation is better applied to Dr. Douglas Stabila. However, yeah, this is probable. Anyway, so, as an example of how classes are actually a useful thing, I thought I might show you guys around a development environment which is standard, pretty standard for video game development at this point, and demonstrate to you how basically everything in it is object-oriented. You guys want to see that, or do you want to move on to the next set of slides immediately? Yes, I want to. Would you like to see it? Because we can just move on. No, it's nothing like that. Yes, okay. So let me explain to you a little bit what it is that I'm about to show you. Ordinarily with software people, you'll find that they often have a sort of project that they're working on in the background in their spare time. It's a really good way to get a portfolio project if any of you want to, actually be employed doing software sometime. It's always nice to have a few portfolio projects in your back pocket. How relevant would it be to everybody else? But I have never seen Unity, so I find it interesting. Yeah, it's well, it's relevant. Does it really? That's cool. Incidentally, there's no difference between Unity and Unity Pro. The free version of Unity is a full-featured version of Unity. There's nothing in the Pro version that's not in the free version. Yeah. So, some of you may have noticed that I actually already have the thing open. So, here's Unity. This is sort of the default Unity look. So, within a Unity scene, and this is a Unity scene, you have a hierarchy of game objects. Of course, in Unity, we don't call them objects, we call them game objects because everything's a game. Excuse me. And then we have a assets folder. This is interesting. The assets folder is actually just a normal folder as you would see it in a Windows Explorer type view. It's a direct view of your file system. But the way that you should think of it is that within the context of Unity, everything inside of the assets folder is a class, and everything inside of the object hierarchy is an instantiated object. You get the tutorial. Oh yeah, it removes the Unity watermark. Yep, that's true. True. Yep. Which is annoying, but, whatever. A thing having the Unity watermark in a game is not nearly so much of a stigmatized thing as it used to be. Anyway, so when the game is running, there are a number of things that are instantiated on the fly in this particular program. So if I run this, I get this sort of field of hexagons, which is actually not these are not hexagons actually. These are actually triangles that are rotating to make them look like hexagons. But each one of these triangles is one of these sprites that's been hooked up to a game asset, which has been predefined in the prefabs. They call them prefabs folder. So this triangle right here, which is a class that inherits a transform object, a sprite renderer, and this script, these are instantiated a large number of times, as you can see here, and that's how you do that. These are all, incidentally, what the purpose of the script is to take a look at some other scripts and see what some values are in them, and that gives you the rotation and the color transformation that's occurring in the background here. So, if you boil all of this down, this is a class. The triangle is a class. Sprite renderer is also a class. Triangle is inheriting the sprite renderer, so it has a sprite renderer. Everything inside of sprite renderer is available to the triangle, and that's inheritance. That being said, you can also have sub-game objects. So, for example, the canvas object, which contains all of these buttons, contains instantiations of a bunch of these buttons, which are, again, objects that have a number of things that they inherit, albeit with slightly different values. So, that's how Unity applies the concept of object-oriented programming to actually do stuff. Are there any questions? Does anybody want me to show them anything else about this? The bridges are a little bit buggy at the moment because I'm still working on them. Recently changed the way that things work. So anyway, yeah, there you go. That is object-oriented programming. If there are any questions about object-oriented programming in general, I'll give you guys some time to write them down at this point. But hopefully that was kind of cool. Yeah, I'm working on it. It's making progress. Okay. So, cool. So, yeah. Honestly, I think that program that I showed you is like 90% of the way there. I just need to sort of tighten up some of the graphics and give it some sound, and you know, in terms of coding, it's like pretty much done. So, well, there's never any shortage of new games. Anyway, let's talk visualization. If you guys were noticing in the background, I have launched a local instance of Jupyter Notebook, which is one of the ways that you guys can now do assignments. So, visualization. What we're talking about when we're talking about visualization here is we're talking about plotting graphs. Sorry guys, this is not how to use how to use Python to make video games. This is not I'm going to teach you how to make Snake, although that would be cool. This is how do you use MATLAB? Basically, how do you use Python like it was MATLAB? How do you make it do graphs and stuff? So, there are many different libraries for plotting in Python. We've got PyLab, PyPlot, and Pandas. For us, we're going to be focusing on PyPlot. However, as with most software packages, some things are better at some things than others. So you should always use the library that is most useful for the thing you are attempting to do. So, if you'd like to install matplotlib, it's an optional set of packages that come pre-installed on Anaconda. They are already installed on JHub 2. So in theory, if you are using either Anaconda or JHub 2, there should be no need to actually look at anything that's on this slide. However, if you are doing some sort of strange non-Anaconda based Python anything, if you want to install it, you go pip3 install matplotlib. So, we're going to focus on getting these to show up in Jupyter because Jupyter has a nice interface for doing this. Just plot everything as polygons in Pygame. Yes, do that. Absolutely. So, we've got two magic commands in Jupyter for using matplotlib. We've got matplotlib inline, which displays the non-interactive images, and we've got matplotlib nbag, which inserts interactive plots that you can scroll around, etc. So let's just focus on the inline version of that for now. Matplotlib inline. And is it going to run? It's a good question. File not found error. Does my local... Alright. Alright. Yeah. Okay, I have to do this in terminal. Well, let's try it anyway. So, import matplotlib.pyplot as pyplot. X values are 1, 2, 3. Y values are 4, 5, 6. pyplot.plot x values, y values, or no, sorry, just x and y, because I renamed those, because that was too much to type, but I typed it anyway. Pyplot.show. Is this just interfering? Haha! We don't actually need the magic command. Oh, maybe I can blow it up. Better? Hopefully that's better. So there you go. It's just that easy. So obviously this is a very simple graph. However, if you have a list, if you have two lists of numbers that correspond to data points in a plot, then you can plot them using this very simple method. Let me just adjust this so that it's not doing that. There we go. So this is your regular line plot. In order to plot a function, we'll need to create a function. So x will be a range from -100 to 100, and y will be x squared for x in, xval. There we go. Just to keep the names distinct. Xval. Pyplot.plot xval y pyplot.show. Ba-bam! There you go. So this is notation that we have not used before. However, it's kind of similar to the prepended if statement formulation that we have occasionally used. Essentially, like if you were to actually ask what y is at this point, it is just a list of numbers, right? So this is just a compact notation for generating a list of numbers. You could just as easily have written something to the effect of for x in xval with y being equal to an empty list, y equals y plus in square braces x squared. And that does precisely the same thing. There you go. So with this particular manner of going about, you can see that this is a very nice smooth line. However, if we reduce the number of plot points significantly with this, make it like 4 and 4, you can see that we introduce this sort of polygon-esque jaggedness, I guess. So the only reason that it appears smooth is because there are so many data points that the transitions in slope appear so small to the eye that they don't appear to exist, and we pick it up as a curve. However, if you zoom in far enough, at every resolution, you will eventually be seeing this with this type of plot. Are there any questions so far? This is again one of these sets of slides that's kind of in the realm of practical things. So, if we want to plot a function that doesn't just use the integers, then you can actually use the third parameter on range to indicate the step value. So by indicating a step value of 0.01, we're saying we're going by steps of 1/100th. If we run this again, we get a type error. Why? Float object cannot be interpreted as an integer. Yeah, which is exactly what we've got here. So if you're looking for that, there's a different type of range object that you have to use called an f range, or a frange, if you were. Could we draw a graph of 1 over x? Yes, we could, sir, or ma'am. 1 over x, there you go. Assuming if x is not equal to 0. Otherwise, we get a div 0 error. Else, we'll just make x, a very large number. Because, it's supposed to be infinity, but a very large number can be approximately infinity if you squint at it. Name error now. F range. What? Custom F range. What? Oh. Okay. So I guess we're going to have to do it manually. That must be from a previous set of slides or something. All right, so I equals 0, while I is less than, sure, that much. X is equal to -3, sure. X, there, x equals x plus x at I minus 1. I will have to start at 1. Yeah. Something like that. Let's see what we get. Oh, I put it inside the bloody thing. Oh, yeah, and also, always increment your counters, folks. And you can see we have our lovely floating point error once again, which will accumulate via this method, so I don't recommend it. It's going all the way up to like 80-something, though. Perhaps we don't need it to go quite so far. Oh. Ah, yes. What am I doing here? There. And we'll remove this print, because that seems to be doing what we want it to now. Let's just make that 0, shall we? Yeah. Okay. Oh, it's still using xval from before. There we go. So, so things are more complicated. Things are always more complicated. It actually worked better when we were using the small range. But anyway, so graph has to approach plus and negative infinity. Yeah, I know. That's the problem. That's the problem. So it would be nice, though, if we got like a nice smooth curve. But yeah. At any rate, my spider sense tells me that there's probably a better way to plot symbolic equations in Python than this. But anyway. Oh. Okay. They are giving us a floated. In the next slide, they're giving us f range. So nice of them to tell me that. So using this f range function, let's see how well it works. Instead of doing all of this nonsense, for x in f range from -3 to 3 by 0.1, let's do it, keep it easy. Let's see what happens. I expected an indentation block. What? Oh, I'm missing a thing. There. This is all right. Well, at any rate, let's stop trying to do fancy stuff. There we go. Anyway, you can see that this is a nice smooth curve, and yet we are on a sub, it's smooth on a sub-integer level. So, so this is, obviously you can apply this to different functions. So if you import math, you can apply, for example, math.sinx, which gives you this very nice sine wave. But that's not the only type of plot that we have available. We also have scatter plots, which are, the only difference here is that you invoke scatter rather than, and that you can see these are all points, scatter rather than pyplot. Let's open up a new thing, actually. So that makes a scatter plot. And, you know, obviously the data that you put in affects the... oh, yes. Oh, thank you. Yeah, so anyway, that's a little bit of visualization. That'll be the topic of the tutorials next week. So, cool. Yes. I'll stay on the line a little bit longer if anybody has any questions, but other than that, have a good weekend, everybody. Not that there's any difference between a regular day and a Saturday these days. Well, anyway, take her easy, folks. Good luck out there.